Hello, welcome to Precision Academic World. We are number one in exam prep, and we are bent to rejuvenating the passion for academic excellence. My name is Johnson Miracle, and I am your facilitator for this class. Here is a digit you can use to call to reach out to us, and this is an email address. Okay, we'll be doing math, and in today's math class, we'll be treating sword and radicals. Let's go into the class and catch some fun. Okay, so by definition, we said, according to my notes, we said sorts are irrational numbers. They are the roots of rational numbers whose values cannot be expressed as exact fractions. Okay, for instance, I think what I'm going to use to express this your sort is that we cannot actually determine their exact value, so they're not determinable. You just have to get their approximate forms. An example of sorts, example, you have your number pi, and then all sorts, the example of sort, examples of irrational numbers. Also the example of irrational numbers. Okay, and then the symbol you use to denote sort, the symbol for denoting sort is the square root symbol. Yes, just like this. That's how we write sort. Okay, so it can be sort 6, sort 3, or whatever. So let's continue. Okay, so let's they said express the following in their simplest form. Okay, actually I couldn't type the question ahead of time, but for some reasons I don't really know how to work with this on the system, but I think I'm cool writing it myself. So sort 45, for instance. Now when you have a number like this is sort 45. One thing about sort that will help you is that you will think about two numbers. One has to be a rational number and the other have to be an irrational number. What do I mean by irrational number? Or a perfect example is, think about a perfect square, a number that has a square root, and right here that's when we combine two of them or multiply them, they will give us 45. So for instance, what numbers can give us 45? 15 times 3, right? Okay, so let me have 15 and 3. Let me get another number. What else can give us 45? Actually, right now my head is just giving me 9 and I think 9. Yes, 9 and 5. So 9 and 5. Okay, so this first number here could give us 45, right? But we cannot work with it. Why? Simple, because they are not they don't really have the perfect square part and then the other integer parts. Why? Because I cannot express 15 as a perfect square, but if I have 9, I can actually express 9 as a perfect square because the square root of 9 is 3, right? Okay, so we'll have to work with this number. So let's do that. So square root of 45 becomes square root of 45. Sorry for that. Becomes square root of 9 times 5. You can do it like this, or you take them separately. Square root of 9, then multiply by square root of 5. Okay, so from here, if you're using this format, you now have 3 raised to the power 2, which is something as 9, right? 3 raised to the power 2 simply means 3 times 3, and that's still going to give us 9. So we're still doing the same thing, multiply by 5 for this format. Right here, square root of 9 is 3, right? So 3 times sort 5. Okay, and then once it's square root of 3 raised to the power 2, you look for a way to bring this 3 outside this square root. So if you're bringing it out, 3 will stand alone and 5 will remain there. And then right here, you now be having 3 times 5 is 3 sort 5. Okay, so why did you really do that process concerning as regards to this place? Let me show you. If we had 3, these topics are related. There is this subtopics 3 sort 5, for instance, and you want to take it back to this form, that is the 45 it was originally. All you simply have to do is introduce the 3 into this sort home or sort platform, raise it to the power 2, multiply it by 5, and then we'll be having that 3 sort 5. Okay, so why would we really do that process concerning as regards to this place? Let me show you. If we had 3 sort 5, for instance, and you want to take it back to this form, that is the 45 it was originally. All you simply have to do is introduce the 3 into this sort home or sort platform, raise it to the power 2, multiply by 5, and then we'll be having that 9, right? Raised to power 2 is 9 multiplied by 5, and that's now going to give us 45. So actually, within here, had something similar. Okay, and that's it. Maybe I want to solve another example that can help us. Okay, we'll have a number. It says sod 98. For instance, how can we simplify sod 98? I told you, whenever you have a sod to solve, just think about two numbers that when you multiply them, they will give you that particular sod. So right now, let's think about two numbers that can give us sod 98. Let me get my calculator and then help myself to an extent. Okay, so let's check for factors of 98. So 98 divided by 3, for instance, what is it going to give us? It makes no sense. We don't need a decimal number in sod. Then let's check 98 divided by 2. Makes sense. 49. So 49 times 2 will give us 98. Wow, and that's making sense. So the two numbers we are getting right now says 49 and 2. So why did I accept 49? Because 49 I can actually simplify it and I get the I get a perfect, I get a square. Like when I take the square root, I can get a number, so it's a perfect square. So that's what I need. So I now progress to, so this is sod 98. I can now progress to sod 49 multiplied by 2, or sod 49 multiplied by sod 2. So from here I simplify to 7 raised to power 2 times 2, and right here is sod 49. The square root of 49 is 7 times sod 2. Sod 2 cannot be simplified. I guess that's, I'm just leaving it like that. Sod 2 is not a perfect square that I can actually simplify. So from here I'm bringing out 7, then I'll have 2 inside, and then from here 7 times sod 2 is 7 sod 2, and that's our answer. So same thing happens if I want to take it back to the original form. It becomes that 7 sod 2 equal to, in one sod platform, 7 raised to power 2 times 2, and then finally I have that 7 raised to power 2 is 49 multiplied by 2, and then I will be having 98. Okay, so let's go ahead and treat some sod rules. Okay, or even solve more instances based on what you have done. So I'd like you to take time and try out this. This is sod 5. I want you to write it as a single sod, and then also have sod 72. Sod 72. Break it down. So I want you to go ahead and try this. Pause this video, try it. Okay, if you're done, let's continue. So this becomes, let's take it into a sod platform. 2 raised to the power 2 multiplied by 5. Remember what I told you last in the previous slide. So from here, 4 multiplied by 5 was giving us 20. So initial sod was sod 20. So for this one, we'll think about two numbers that can give us 72, right? Okay, so let's check two numbers. Let me consider 8 times 9. 8 times 9, 72. Okay, so it means that the two numbers we need that can give us this is 8 and 9. So 8 and 9. So I think I'm okay with 8 and 9 because 9 is a perfect square. So I think I want to use it in this one. Let me just interchange them, 9 and 8. So sod 72 is equal to sod 9 times 8 or separately. But please don't solve with the both method. I'm just doing this for record keeping and to help you understand. But if you're solving, either use this format, this method to solve, or this method. Don't try combining both of them. Don't go into those kind of stress. So from here I know that 3 raised power 2 is 9 multiplied by 8, and then right here I have that okay, sorry, this is 3. This is 3 multiplied by sod 8. So right here we can be having 3 sod 8 and then 3 sod 8. Okay, I think I just saw this question sometime where I had something related to this, but oftentimes I know sod don't usually have big numbers here. They are being simplified to their simplest form. They are being simplified to their simplest form. So it might not really be ideal to have a big number as 8 inside this sod. So let's give it another approach. So 72, which number can give us 72? I think 12. So let's just 72 divided by 12. 72 divided by 12, what is it giving us? 6. So let's check. Sod 72 is equal to sod 12 multiplied by 6. Okay, it's not really making sense because 12 is not really a perfect square. It's not a perfect square. So let's check number like 16 and check if we're gonna get what we want. So 72 divided by 16, 4.5, not still making sense. Okay, 72, let's check 72. Actually I'm just doing this calculator because I want it to actually flow with me. Personally, if I'm the exam hall or I want to solve this, I think I can just run because somehow I'm already used to the numbers. So divided by 16. Okay, we'll try 16, right? Just right now we'll try 16. So 72 divided by 36, and that's 2. So you look for small numbers in the sort platform. So just keep trying numbers. I know why I just solved this using this format, because I just wanted you to go with something you're easy with. But I won't advise you for this because this number is too big to be in the sort section. You look for the smallest number I can simplify. Are you getting? Okay, so let's use the right approach for that. I just use that so that I can actually be able to explain this to you. So for here we'll have that sod 72 is equal to sod 36 multiplied by sod 2. And then now why am I going to work with this number? This is a perfect square. Are you getting? So 36 is just 6. 6 multiplied by sod 2 will now give me 6 sod 2, and that's my answer. So this is what's actually needed to solve. So I think this approach is more preferred, is more valued compared to this other approach where you have big numbers here. Okay, addition rule of sod. Okay, so I'm going to be using variables to explain this addition rule, and then we'll go ahead and solve questions based on that. Okay, so for instance, when we have sod A plus sod B, it remains sod A plus sod B. So for instance, sod A plus sod B can never give you sod A plus B. No, it cannot give you that. It's not possible. That can only be applied in multiplication. Okay, so let's, for instance, solve a question based on what I just said now. So we'll have a question that says sod 32 plus 3 sod 8. That is and I didn't tell you under name for sod radicals, but I know I wrote it in my notes. Radicals. So radical 32 plus radical plus 3 radical 8. Okay, this 8 is too big. Like I told you, have to break it down. And this one also have to break it down. So what two numbers will I multiply to give me 32? I think 16. So I have that sod 16 times 2 is same thing here, right? Plus 3 sod 4 times 2 is same thing as 8, right? I just simply say that sod 4 raised to the power 2 times 2 plus 3 sod 2 raised to the power 2 times 2. So bringing these numbers out, I think I want to continue here. It becomes 4 sod 2. We've been doing this, and then plus 3 bracket 2, which is this number 2 sod 2. I'm just using brackets. I will not get things so choked up or confusing. So 4 sod 2 is here. 4 sod 2 plus 3 times 2 is 6. 6 sod 2. Another approach you can use, I think that might be more ideal, is once you have from this part, I want to start from this part, just say sod 16 multiplied by sod 2 plus 3 in bracket sod 4 multiplied by sod 2. So sod 16 is 4, because square root of 16 is 4, multiplied by 2 is 4 sod 2 plus square root of 4 is 2 multiplied by, sorry for that, it will not give you a square root again. Square root of 4 is 2 multiplied by sod 2, cannot be simplified, so you'll be having that 4 sod 2 plus 3 bracket 2 sod 2. So 4 sod 2 plus 3 times 2 is now 6 sod 2. So they actually exactly the same thing. Okay, I have this question and I want you to go ahead and try this question on your own. Okay, 7 sod 3 minus sod 75. Actually exactly the same thing, because we still have same what is it called, we'll have same sign, just that it's minus now, but before it was plus, right? Okay, so let's go ahead and simplify this. If you want to simplify this, what are we meant to have at the long run? So this one has been simplified already. Let me highlight it. You don't need to struggle with this part. 7 sod 3 is on the smallest or simplest form. Don't need to work on that again. Like, there's a popular saying that says you don't work on perfection. So 75, let's work on 75. So what number can we multiply to give us 75? Now we have to think about two numbers. One has to be a rational number and the other have to be a perfect square. So I think 25 is good. So 7 sod 3 minus sod 25 times sod 3, because that's going to give us 75. So from here, 7 sod 3 minus square root of 25 is 5. 5 times 3 is sod 3. Now they have same sod, right? I want you to observe this. They have same sod 3 and same sod 3 in common. Because they have same numbers in common, we can combine them. So can I say that for the number aspect, 7 minus 5 and then sod 3. So 7 minus 5 is what? 2, and then we'll now have sod 3. So that's the final answer for such kind of question. So all I want you to do is, I want you to get to your books, your textbooks, review some of this topic, and then work alongside with the video. That's going to be a very helpful material for you. Okay, so okay, so let's go over to multiplication of sod. Okay, so for instance, when we are dealing on sod A multiplied by sod B, actually we can have sod AB. They can come together. Not so, same does not apply for addition and subtraction of sod. Okay, so let's say we have a sod 45 multiplied by sod 28. Okay, the rule here, you have to be very, very creative in thinking. Think about two numbers that whenever we multiply them, they're going to give us 45 and then they also give us 28. But note that one has to be a perfect square and the other an irrational number, which is a surd. Okay, so let's go ahead and make sense out of this. So 45, 9 times 5 is going to give us 45, right? Okay, so let's, for this aspect, to say 9 times 5. Remember, 9 is a perfect square and 5 is not. So what else can give us 28? 4, 16 times 2 cannot give us, so 16 will not work. So let's check 4 times 6. 4 times 6, right? 4 times 6 will give us no, 4 times 6 is not 28. 4 times, I'm thinking 7. Okay, so let's go ahead with that. 4 times 7. You just have to take your time, think. That is where the surd plays a good role. It helps you to think, and if you're not good with multiplying numbers, that is multiplication, you might not really do well in this surd. Okay, so 28 divided by 6, let me check. Okay, that's not going to work. 6 is not going to work, but let's check 28 divided by 7. 28 divided by 7, yeah, 4. Okay, so 4 times 7, right? So from here, let's simplify this. This is 3 raised power 2 multiplied by 5. Now I'm using the other approach. Any of the approach you prefer, work with that. 2 raised power 2 multiplied by 7, and then bring the 3 out, then 5 remains there, 5, and then times 2 surd 7. I don't know if you actually follow to this part. So from here we now have the number part and the surd part. So this is the number part and then this is the surd part. Okay, so what you just do, combine these terms from here. So from here you're going to be having that 3 multiplied by 2 and then surd 5 multiplied by surd 7. Do you know why you can combine now? In addition and subtraction of surd, you cannot combine the surd parts if they are different, but in multiplication you can do that, and it only holds for multiplication. Okay, so 3 times 2, I want to continue from here, is 6, and 7 times 5 is 35. So surd 35, and I don't think there's any two number that can express 35 as a perfect square and then an irrational number. I don't think so. That will bring us to the end of the multiplication. But I also want you to know that, for instance, if you have okay, I'm going to treat the rule later. Okay, for instance, surd 2 multiplied by surd 3. Whenever they multiply, for instance, this is going to give us surd 6. So just multiply the numbers, keep the surd. So let's say surd 8 multiplied by surd 3, that is surd 24. Just multiply the two numbers, keep the surd. So that's it. Okay, let's go over to the next slide. Okay, when surd multiply themselves, I think this where I wanted to explain something. So for instance, surd 3 multiplied by surd 3 is 3. When they are multiplying themselves, I want you to take note of that. So when a surd is multiplying itself, and then surd A multiplied by surd A is just A. So surd minus 1 multiplied by surd minus 1 is just minus 1, and surd 4 multiplied by surd 4 is just 4. So what you do is, when a surd is multiplying itself, just pick the number right there. So let me prove this with some rule, with some numbers. So let's say surd 2 multiplied by surd 2. Remember surd rules, because they are the same, because they are multiplying, let's take them together. So it becomes 2 times 2, right? And what is it going to give us? 4. And square root of 4 is what? 2. Okay, let's do for 3. So surd 3 times surd 3, that's what? Let's take it together. 3 times 3 is what? 9. So surd 9, and the square root of 9 is what? 3. Same thing happens. Are you getting it now? So whenever I saw this multiplying itself, the result is just that number. Okay, division of surd. Okay, when we have two surds dividing, like surd A over surd B, so based on the situation, we can take them separately or we can take them together A over B. So any of the ways is still good to actually work with for your SOD division. Okay, for instance, I can have SOD 7 over 2. The same thing when I say SOD 2, SOD 7 over SOD 2. Okay, let's see this question now. It has SOD 50 over SOD 2. Just simply combine it, SOD 50 over 2, and what's it going to give us? 50 over 2 is just 25, so SOD 25, and square 25 is what? 5, a single number. So just always check out for what's going to actually work for you so easily, and then while dividing it, then with your intuition you can now simplify down to what you actually want, like the desired form you want that question to be. I don't know if you get that. Okay, so we'll have, let's do this. We'll have SOD 60 multiplied by SOD 180, SOD 60 multiplied by SOD 180, all over SOD 75, SOD 75. Actually, these numbers look kind of big, but it's not really a challenge. So is there any two numbers that I can use to separate this and will give me a perfect? Okay, so I forgot to put this SOD 60, so let me do it here. So just SOD 60 multiplied by SOD 180 all over SOD 75. So let's multiply together. SOD 60 times 60 times 180, 1000. Okay, let's 1000. Okay, 10,800. Okay, so we'll have that SOD 10,800 over SOD 75. Okay, so let's continue here. But remember the rule of SOD, we can combine them. So let's just take one single SOD to combine them. So 10,800 divided by 75. So let's do that. 10,800 divided by 75. What's it giving us? 144, right? Okay, so SOD 144 all of, okay, nothing again, so we are done, right? We don't have any other number right there. Okay, so SOD 144, square root of 144 is 12, right? And this 12 becomes our final answer. Okay, but in some cases when they don't give you some of this information that you will need, for instance, let's say SOD 25, sorry for that, let's say for instance you have SOD 25 over 4, right? Now you know that SOD 25 and SOD 4 and 25 and 4 can never divide, right? Just simply take them separately, which is SOD 25 over SOD 4. And what is it going to give us? Square root of 25 is 5 and square root of 4 is 2. So this will be your answer. I don't know. So based on the way the question is being set, you can now know how to arrange it, or know the perfect approach you will use to attack that particular question. Okay, rationalization of SOD. Okay, so we're now into the last lap of this before we start solving some questions. For instance, if I have a number like 3 over SOD 2, you know this is a fraction and the number on top is the numerator. Let's just do that, and then this one is, let's just do that, this is numerator and this is the denominator. Okay, now denominator does not stay in a SOD, like the denominator part cannot be a SOD number. That is what I want to explain here. So a SOD cannot be the denominator of a fraction. That's completely wrong. Please, dear students, dear friends, anytime you're solving for SOD and you're having a SOD in the denominator section, that's completely wrong. You have to move it away, and the only principle of SOD that can help you move it away is rationalization of SOD. So let's go ahead and solve this question for you to understand better. So where I'm having 3 over SOD 2, To rationalize, I will multiply this number by the denominator. So I'll have sod 2 over sod 2. That is the meaning of rationalization. So I'm multiplying it by the same number. So 3 times sod 2 is 3 sod 2 over sod 2 times sod 2 is 2. Remember, I told you about this rule. Whenever sods are multiplying themselves, I think I want to highlight that so that you can get your attention fixed to that. So that will give us only 2. Okay, so let's say for instance we had 2 over 5 sod 3. A sod cannot stay here, so let's multiply by what? What are we multiplying by? By sod 3. We need to move away. That's I getting me. So you're only working with the sword. I getting me. So you need to move away that sword. So from here, 2 times sod 3 is giving us 2 sod 3 over sod 3 times sod 3 is what? So I have my 5 first here, and then 3 times 3, so 3 times sod 3 is 3. Now we're having that 2 sod 3 over 15. Okay, let me do one more example and then we'll call it a moment. So let's say for instance we'll have 5 over sod 7. So multiply both sides by what? Sod 7 over sod 7, and then you'll be having 5 times sod 7 over 7. Why are we doing this? Because we don't want to have a sod in the denominator, and I know right now you can see that. Okay, let's do this one lastly and then we'll call it a moment. Okay, it's okay. Let's just go to conjugate of sod. I think we are the last lap. I would like you to just hang on and pay attention where we'll finish up with this, right? Let's go. Okay, so the conjugate of a sod, for instance, if we have I think this conjugate was actually derived from difference of 2 square. We don't need to start going through those whole lot of things. So let's say for instance you have sod 3 plus sod 5. The conjugate of this sod becomes sod 3 minus sod 5. So let's say sod 2 minus sod 4. The conjugate becomes sod 2 plus sod 4. So imagine the conjugate are just changing the sign, and I'm going to show you where you will make use of the conjugate. Not really now, but we're going to definitely work with it. I hope you understand. Okay, so let's say sod 5 plus sod 6. Just simply change the sign. That is, the conjugate becomes sod 5 minus sod 6. Okay. Okay, let's continue. We'll have a question to solve. So they say simplify. I should simplify this sod. Simplify. We'll have now I told you about this rule that is on rationalization, that a sod cannot be in the denominator section, right? So we're going to actually remove this. But now I want you to know something. We have 2 sods, no longer 1. Unlike in rationalization, I showed you 1, but we're going to use both conjugates and rationalization to solve this question. So we'll be having that 3 over sod 3 plus sod 2. So what you just simply do, take the conjugate and then rationalize it. So multiply by this number becomes sod 3 minus sod 2 because of conjugate. And then why are we multiplying by same number? Because of what? The rationalization. So sod 3 minus sod 2. So when we multiply this, we'll be having 3 brackets. Remember algebraic multiplication minus sod 2. So this number is multiplying these 2 numbers, right? And then all over here we'll be having that sod 3 plus sod 2, then bracket sod 3 minus sod 2. They have to multiply each other, right? So the first bracket is multiplying the second bracket. So what I want to do right now is that for the numerator, 3 times sod 3 is giving me 3 sod 3, and then 3 times negative sod 2 is giving me negative 3 sod 2. Okay, all over. So I want to multiply this number. So what I do is the first bracket to multiply the second bracket. So the first bracket I have sod 3. So sod 3 brackets this second part, sod 3 minus sod 2. And then I think I understand this line. Then this part plus sod 2. Please pay attention to this, it's not really hard. Bracket sod 3 minus sod 2. Now remember that first of all we had this one multiplying sort 3 minus sort 2, and then sort 2, which is right here. I think I want to just highlight that to get your attention. This sort 3 now is same number here, and it's multiplying everything in this bracket. Now this positive 2 is same number here, multiplying everything in this bracket. So in the numerator section, since seems like we're almost done. Okay, let's continue. So we have 3 sort 3 minus 3 sort 2 in the numerator. So let's continue. Sort 3 times sort 3 will give us 3. Remember the rule? Then sort 3 times 2 will give us negative sort 6. So negative sort 6. I've gone through this rule. You can just pause this video or take it back. You will see where I stated all these rules. So plus sort 2 times 3 is also giving us sort 6, and then sort 2 times sort 2 is 2, but remember minus, so minus, just minus 2. I want you to observe closely that minus 6 plus 6 goes away, that's 0, so goes away, and then we'll now be left with what? 3 sort 3 minus 3 sort 2 all over 3 minus 2, and finally we'll be having that 3 sort 3, sorry for that, 3 sort 3 minus 3 sort 2 all over 1, and any number divided by 1 is just that number, right? So 3 sort 3 minus 3 sort 2. So why can we not combine these numbers? Because they are not multiplying, and then 3 is not common with this. If not, we would have combined, and then we cannot just multiply them because they are not actually multiplying. The rule holding them right now is subtraction. So let's still apply the same approach here. That's going to be very much helpful. Okay, so because we have a sort in this section, it means that's not really going to help us. What do? So we're gonna conjugate, right? We're gonna conjugate and rationalize. So 2 plus sort 3 all over sort 2 minus sort 3 multiplied by sort 2 plus sort 3 all over sort 2 plus sort 3. So this part we're going to be having that 2 plus sort 3 is going to be multiplying everything in this first part, sort 2 plus sort 3 all over this one, sort 2 minus sort 3 is going to be multiplying everything in sort 2 plus sort 3. Okay, so I think I want to actually erase this part so I can use part of the board. So either you pause it and copy the notes, and that's it. So just hang on a little bit, but I hope this is actually making sense to you. Just take time, review your sword notes, and then watch this video. That's going to be a very good guide for you. Definitely you will learn this. Okay, so I'm continuing from here. So for here, let me use this first number. So 2, okay, let me still get rid of this one, so don't be offended for that. Let me still get rid of these numbers. Okay, so 2 multiplied by everything. So this first bracket is multiplying the second bracket. So 2 brackets sort 2 plus sort 3, then plus sort 3 bracket sort 2 plus sort 3. All over, so we're having right here this, please don't let this distract you. So sort 2 multiply everything here, so sort 2 brackets, that is this sort 2 multiply by everything here, sort 2 plus 3, okay, and that is sort 2 plus sod 3, and then minus sod 3 bracket sod 2 plus sod 3. Okay, 2 times sod 2 is going to give us 2 sod 2 plus 2 times sod 3 is 2 sod 3 plus 3 times sod 2, sod 3 times sod 2 is sod 6 because they are both sods. Then plus sod 3 times sod 3 is only 3. Remember the rule. So all over 2 times 2, so 2 times sod 2 is 2 plus 2 times 3 and both sod, so sod 6 minus sod 3 times 2 is minus sod 6, then minus times plus is minus, so 3 times sod 3 is just 3. Now I want you to observe this thing. Anytime your sod is correct or virtually all the sod questions I've solved, you can cancel out these two numbers. Yes, because it's plus sod 6 and minus sod 6, so minus plus and plus minus to cancel out, right? Okay, so we'll now be left with let's combine. So these two numbers cannot actually add because they have let's say they don't have the same sod. This is sod 2. Let me highlight this. Sod 2 and sod 3, they cannot actually add, right? Okay, so maybe let's just continue solving. So 2 sod 2 plus 2 sod 3 plus sod 6 plus 3 all over 2 minus 3. That's from here to here, 2 minus 3, and that's giving us negative 1, right? Okay, negative 1. So 2 sod 2 plus 2 sod 3 plus sod 6 plus 3 all divided by minus 1. And that's it. You can just simply take the minus up by saying that minus bracket 2 sod 2, that's this part of the question, plus 2 sod 3 plus sod 6 plus 3. Okay, and that is it for this particular class. Okay, wow, so let me just try to check if I can get more questions, and then we'll solve and then call it a class. Now the stuff I always that I want to tell you is that please don't just watch this video and stop. Go to your textbooks, get questions, try them on your own. That's the best way to learn. That's the best way any student can learn. Okay, so I have another simple question, very much simple. It says sod 2 plus sod 5 plus sod 5 over sod 10. Now remember, sod cannot stay in the denominator, right? So we rationalize sod 2 plus sod 5 all over sod 10 multiplied by sod 10 over sod 10. So right here we'll be having that sod 2 plus 5 plus sod 5 is going to be multiplying by sod 10. So sod 10 will multiply these two numbers all over, then sod 10 times sod 10 is just 10. Hope you understand. Okay, so 10 times 2 is 20, but remember, because it's a sod, it will give us sod 20 plus 10 times 5 is 50, so sod 50 all over 10. So we are done with the denominator. Let's look for one, fix the numerator. So sod 20 is same thing as, okay, let's break it down. Two numbers that can multiply to give us 20. One has to be a perfect square and the other has to just be a normal number. I think 4 times 5, right? So sod 4 multiplied by sod 5 plus for 50 we'll have sod 25 multiplied by sod 2 all over 10. So this is square root of 4 is 2, so 2 times 5 is 2 sod 5 plus square root of 25 is 5, 2 times sod 2 is sod 2 all over 10. Okay, so if we write them separately, it becomes 2 sod 5 over 10 plus 5 sod 2 over 10. This is just a further work. So here is 1, here is 5. So sod 5 over 5. Right now you can see there is no sod in the denominator section. So that really makes sense. So let's continue here. 1 here and then 2. So we have sod 2 over 2. And if you also observe, there is no sod in this denominator section. Wow, I'm just darkening the number. So 5. Okay, and that's it for that one. Okay, so let's still try another question and then we'll call it a moment. But hope you're having a good time, because personally for me, I've been enjoying the class from the onset. So 2 plus sod 3 over 7 minus sod 5. So what do you do here? I want you to go ahead and try this question on your own. Pause it, make sure you try it. So let's continue. So let's conjugate. So conjugating and rationalizing, will multiply by this denominator, but we'll change the sign on top. So it becomes 7 plus sod 5 all over 7 plus sod 5. I just change the sign and use same number to multiply through. So here we'll be having that 2 bracket 7 plus sod 5, then plus sod 3 bracket 7 plus sod 5, and then here is 7 bracket 7 plus sod 5 minus sod 5 bracket 7 plus sod 5. So what I did was that I used this number to multiply everything here, everything right here. I use this number, and I also use this number, which is there is this first part, and then also use sod 3 to multiply this part. So then I use this 7 to multiply everything here, and also use negative sod 5 to multiply everything here. So let's continue. Okay, so 2 times 7 is 14 plus 2 sod 5, just multiply to give us 2 sod 5, plus 3 times 7 is, okay, they cannot multiply, so 7, it gives us 7 sod 3, then plus 5 times 3 is 15, same sod, gives us sod 15. That is, both of them are sod numbers. So 7 times 7 is 49. 7 times 5 is, okay, 7 times sod 5 is 7 sod 5, minus this 7 times sod 5 gives us minus, because of negative, minus 7 sod 5, then sod 5 times sod 5 is just 5, then minus, so minus 5, not minus sod 5. Okay, so let's continue from this part. So is there any number that we can use to break 15 into a perfect square? 3 times 5, 15, but 3 is not really a perfect square, right? Okay, let's continue anyway. So 14 plus 2 sod 5 plus 7 sod 3 plus sod 15 all over, remember these two numbers are cancelling at 7 sod 5 and 7, both of them are cancelling at, so we'll be having that 49 minus 5. Now I want you to note something. Whenever you are solving, I think in your sod and you have let's say a whole lot of numbers, there are two numbers here, they must cancel out. Okay, so 14 plus 2 sod 5 plus 7 sod 3 plus 15 all over 44, right? Okay, one thing I want to let you know is that this kind of questions, I think, to me, I'm okay solving it, unless you wish to solve. Okay, this is sod 15, not just 15, this is sod 15. Unless you feel there is something else you need to do, something special you can do to solve it, then go ahead with that. But for me, I think I'm just cool with this answer, and that's it. So I want you to go through your textbook, solve more questions on sod, and that's just it. Okay, so I want you to attempt some questions which I'm going to give to you right now. I want you to solve this question. 4 over sod 8. Please solve it. 4 over sod 8. Sorry for that. 4 over sod 8. Okay, so also solve 4 over sod 5 plus sod 3. So in conjugate, change the sign to negative. Okay, and then do I have any done? Okay, try this one too. 3 over 2 sod 6 minus sod 3. Please make sure you try these numbers on your own. That's the best way I think you can actually learn this. Wow, it was quite a long one, but we made it through. Wow, thank you so much for being a part of this class. I really do appreciate. And I will advise you to go through the video once again. Maybe if you don't really understand some part, pause it. I don't know if you get my point. Pause it. Try to solve it. Work alongside with your textbook. My name is Mr. Johnson, and I got it covered for your math and sciences. I am one of the officials at Precision Academic World, and we are the official host of Precision Academic Competition and a whole lot of more to support students in their math and sciences. So we are bringing this to you to help you prepare for your forthcoming exams and all that. Okay, so thank you so much for being a part of this class, and I will tell you, you're just an inch away from me, so reach out to me, let's work together, and the rest of your story as concerned with your academics will be greatness and turnaround.